Over the next couple of videos, we're going to be talking about neural networks. And particularly, we're talking about artificial neural networks because we're using machine learning to replicate how neurons in the brain work and replicating how humans or simulating how humans learn. So we're creating an artificial neural network. So let's talk about what we mean by neural networks. Neural networks are a type of deep learning that assumes some hidden layers of information between inputs and outputs. So that output could be identifying an image, a picture, saying this is a cat or a dog. It could be predicting what a Apple stock price would be. It could be identifying sentiment as a positive or negative review. And the input then is going to be multiple variables if we're doing classification or regressor type models where we're trying to determine if it's a penguin. We look at different physical features. Those are the inputs. But it identifies hidden layers in between that input and output. So it's adding a layer of complication that, say, the regression or the classification models don't have, because it's assuming that there's some underlying variables that can't be seen. Maybe that's lags or relationships between those inputs or additional variables that would kind of explain how we get from that input to the output. So it's looking for patterns that can't be detected just by simply looking at the inputs. Now, when it comes to types of neural networks, we have feed forward, which is where information is shared in one direction. So we go from inputs, we alter those inputs to create this hidden layer. It goes to the next hidden layer, then it's amended, it goes to a next hidden layer. You might have multiple layers, and then to the output. So we're moving in one direction with the information. How the neural network then learns is what is called backpropagation. So this is an iterative process where after the data is sent through the neural network, so we get our output is then assessed. How well did it perform? If we're looking at classification, how accurate was it? If we're looking at linear type regression, how much mean square error did we have? And so then what we're doing is going back through again. See that back through again after having adjusted the weights and some of the hyperparameters, and then sending it all through again to see if that improves the accuracy or if that changes or decreases the amount of measurement error measured in terms of mean squared error or mean absolute percent error. So the back propagation is with the feed forward. We go all the way through and then we go around after tuning it and go through it again. That is different than a recurrent neural network where we have bidirectional movement. With a recurrent neural network, information can go backwards. So we have the feed forward where information goes from inputs to hidden layers, but with recurrent, information can go back to earlier layers. And so recurrent is going to be used for time series type data where we're looking at changes over time. And by adjusting and looking at and being able to amend kind of weights and things from just a step or two before, we can look at lags, we can look at the relation to things in time. When it comes to text, this allows us to identify themes because we can get context out of the fact that we know how words are near each other. We know if they say they, we know that a couple of words previous or based on the words around it, we know who they are. And so that recurrent is going to be, that bidirectional is going to be beneficial when we're looking at things in time or the order of things. As opposed to feed forward, we're looking at more specific words, specific pixels as we look at images, and not so much worried about kind of that context in terms of what's around it. So feed forward and then bidirectional allows us to move back a couple hidden layers and do some adjustments. To do neural networks, there's a couple of things that we need to make sure that we do. First, we need to standardize. When we have variables that are interval or ratio, neural networks are highly sensitive to how different the different variables are, so always standardize. Whereas when we talked about in regression analysis, that we don't always need to standardize. Logistic regression doesn't require standardization, for example, but linear regression does. So that's one thing to keep in mind. The next is that you need to do one hot encoding. One hot encoding is where you take nominal and ordinal data and you turn it into binary. So for example, the part my face is covering up is that when it comes to this penguin data set, for example, we can't have 3 different species in one variable. We have to hot encode it, which means one variable called Adelie, one variable called Gentoo, one variable called Chinstrap. So one hot encoding is where everything is turned into binary if it is not interval ratio. Okay. All right. So now that we've done that, let's talk about types of neural networks. There are a number of different types of neural networks. Okay. And so I have a slide about MLP. Yeah. So there is these multi-layer perceptrons. These are called vanilla neural networks. And they are fully connected neurons. We'll come back to them. They're kind of the most simplistic of them. They're very similar to the classification regression, the logistic regression and the linear regression that we've done in some previous videos. So we'll take a look at how to do those, specifically in Python. But when we talk about neural networks, the big key ones are convolution neural networks, graph neural networks, recurrent neural networks, and general and adversarial networks. Okay, CNN, GNN, RNN, and GAN. What do we mean by any of these things? Okay, convolution neural network. The convolution neural network, CNN, is feed forward. So if we go back just a sec to where we were, that means we're going one direction through the neural network, and we're using back propagation to change the weights and hyperparameters to adjust it and then going through it again, okay? As opposed to the recurrent, which adjusts and goes back to those different ones. Oh, I skipped a slide. So we have here a convolution neural network. An example of a convolution neural network would be like here, this picture has hidden layers, right? Certain colors, it might identify this feature here. It's a tail shape. We have a tree shape, a snout shape. And so we learn from a bunch of images that there's these hidden layers that we should look for, and that would then lead to the classification of a dog. The risk, of course, is that if you feed it a lot of input that has a picture of a tree, it then begins to look for tree shapes to classify the dog, and if you don't have a tree, or it thinks the tree is the dog. All right, so when we do our convolution neural network, we use this for things like sentiment analysis, where we are looking at which word comes next, so syntagmatic association, and we talked before about word2vec as one of those. We also use CNN for images and video processing, like identifying that picture of a dog. And CNN is particularly important when there's some kind of hierarchical aspect to the data. That's why with sentiment and images, we use CNN, because we're essentially building the pieces of the image or multiple words that start to tell us that people feel a certain way. So for example, with the CNN, we can see here, we would start with an input, which is this picture, and we would have a feature map, and it starts to learn to look for certain features. So it starts with lines. Then it's going to look for edges. Then it's going to find that that edge is going to be parts of legs. And so there's a hierarchical nature to it where we start with some little piece, and that little piece gets combined with other little pieces to make a shape. And then that shape gets combined with other shapes to make a bigger shape. And so this hierarchical aspect, we're building the image essentially and identifying the image based on taking these little pieces and connecting them to other pieces. Okay. All right, so when it comes to, there's a special case of convolution neural networks. It is called graph neural networks. So you recall our videos on network or graph theory, graph models. And so you can actually do neural networks with graph models. Like here we have nodes and edges that show how information or events impact other events or people, so the spread of information, the spread of disease. We can use these graph neural networks for things like sound and weather, so we can see how one weather event impacts another weather event, another location, or another type of event. Same thing with sound. And so these graph networks of data, they look at that interconnectedness between events or people. Okay. So graph neural networks, a big new area in neural networks. In comparison, we can look at recurrent neural networks. So recurrent neural networks are bidirectional, which means that we don't have to go all the way through before we update the hyperparameters and then go through it again to improve it. It is bidirectional so that you can go back to those hidden layers and update information, which means it can be used for themes. We talked before about BERT, and so that would be a recurrent neural network. And it looks at paradigmatic association. So similar words surrounding a word must indicate similar meaning. So we're looking at different parts of speech. We're looking at where words are positioned relative to others. So as we said, we could identify, what the they is in the sentence. So recurrent neural networks are going to be used for analyzing more sentences, themes, and documents in more detail. And then we have what is called the general adversarial network. And the general adversarial network is what generative AI, so Midjourney that creates images, ChatGPT that creates text. And what this is it's multiple convolution neural networks that are set up to do things like identify a dog. And then you have reinforced learning, where one CNN is set adversarially against the other CNN. So one identifies the image of the dog, the other one is looking at creating the image of the dog, and then they are learning from each other through a reinforced learning process. So this is how we get that image creation when you tell all the pictures you've seen in these things, like the little dog in the tree. Yeah, there you go. These are all Midjourney generated, right? I gave it a prompt. I told it, give me a cartoon of a dog, and it gives me this picture here. So that is created through this general adversarial network. Pairs of CNNs that are set up against each other in an adversarial scenario, and then using reinforced learning to learn from each other to help tune and improve the CNN that is identifying the image and the CNN that is creating the image. In our next video, we'll talk about how we set up a neural network, and then we'll get into building them in Python.